Hello and welcome to this tutorial on binary search tree. Today, we'll explore one of the most fundamental data structures in computer science. A BST is a hierarchical structure that organizes data for efficient searching, insertion, and deletion. The unique feature of a BST is that for every node, the values in the left subtree are smaller and the values in the right subtree are larger. A BST consists of nodes where each node contains three main components. We have the value, or the data stored in the node. Left child points to the left subtree containing values smaller than the node. Right child points to the right subtree containing values larger than the node. Key properties of BSTs. The left subtree contains nodes with values less than the parent node. The right subtree contains nodes with values greater than the parent node. Duplicate values are generally not allowed. A binary search tree is made up of nodes. Each node stores values, and it may have up to two children. A left child for smaller values, and a right child for larger values. This organization ensures that BST operations are both efficient and intuitive. Operations in a BST. The first one we have insertion. Insertion involves finding the correct position for a new value. We start at the root and compare the value to be inserted with the current node. Depending on whether it's smaller or larger, we move left or right until we find an empty spot. Let's have an example. Let's begin with the binary search tree. The root node has a value of 50. And the item to be inserted is 100. Since 100 is greater than 50, we traverse to the right subtree. Now, the current node has a value of 70. Again, the item 100 is greater than 70. Therefore, we traverse further to the right subtree. The current node is now 90. Since 100 is greater than 90, we identify the correct position for insertion. This will be the right child of 90. Finally, we insert the value 100 as the right child of the node with the value 90. The binary search tree is now updated. Inserting a value in a BST is like navigating a maze. Starting at the root, we compare the value with the current node. If it's smaller, we move left. If it's larger, we move right. This process continues until we find an empty spot. The second one is searching. Searching in a BST is efficient due to its structure. Starting at the root, compare the target value with the current node. If they match, the value is found. Otherwise, decide whether to search in the left or right subtree based on the comparison. Let's have an example. Let's walk through the steps to find an item in a binary search tree. In this case, we are searching for the value of 60. We start at the root node, which contains the value 50. Since 60 is greater than 50, we move to the right child of the root, which is the node containing 75. Now, we are at the node with the value 75. Since 60 is less than 75, we move to the left child of this node, which contains the value 60. We have reached the node with the value 60. Since the item matches the value of this node, we return the current node as the result. To search for a value, we start at the root and compare the target with each node. If it's smaller, we search left. If larger, we go right. This continues until we either find the value or reach the dead end. The third one is deletion. Deleting a node in a BST involves three cases. Left node, node with one child, node with two children. Left node, simply remove it. Node with one child. In this example, we're deleting the node with the value 13. Start by locating the node to delete, which is 13. Since 13 has a one child, which is 14, we replace node 13 with its child 14. After this, the updated tree maintains its binary search tree properties. Node with two children. In these examples, we're deleting the node with the value 18. Locate the node to delete, which is 18. Since 18 has two children, we find its in-order successor, which is the smallest value in its right subtree. In this case, the successor is 19. Replace the value of node 18 with its in-order successor 19. Finally, delete the in-order successor 18, which is now a simply leaf node. In this tutorial, we cover the basics of binary search trees, including their structures and operation techniques. Understanding BST lays the groundwork for mastering more complex data structures algorithm. Thank you for watching.